All right, fingers crossed that this is working. I guess we'll find out when I'm done, if it doesn't work or not. Okay. So 1-5, last section we're going to do of this chapter, and it's luckily not super long. It's over here. Grab our fancy notebook. All right, so 1-5 is on postulates and theorems. Postulates and theorems. Okay, so the first one we're going to talk about is, we're going to make a list. We have some postulates and then we'll talk about some theorems. So the first one is that a line contains 2 points. Another way to say this that you're going to see it more commonly is that 2 points determine a line. So either way, both of these things are basically saying the same thing. And in plain English, it's the following. Well, let's do this little activity. Draw on your paper. It doesn't even matter where. Put a point A anywhere on your paper. It doesn't even matter. Put a point A. I'll do it too. I'll put a point A right here. And then pick some other random point on your paper. It doesn't matter where. Put a point B. I'll put a point B over here. Couldn't I give you all a ruler and couldn't you connect points A and B? Couldn't you do that no matter what? If you only have 2 points, couldn't you always connect them? What if one of your points wasn't even on the paper? Imagine I wanted to connect my point A that's here on the screen here, right? And I want to connect it with a point J that I put on the back wall. Now, I couldn't physically take a ruler and connect them and draw the line because I'd be drawing in the air, right? That would be kind of hard. I couldn't do that. But could you imagine a laser beam that connected those 2 points? The one on my desk and one on the back wall? Could you imagine if I put one dot on the ceiling and one dot on the floor? Couldn't I connect them with a laser beam? If you imagine one dot here and one dot in Japan, couldn't you envision a laser beam that went through the earth and connected the two? So what it basically is telling us is that it does not matter where the 2 points are. Any 2 points and the entire galaxy are going to be collinear. I can make a line that connects those two if I'm just talking about 2 points. Once I start talking about 3 points, okay, that's a different story. So if I were to ask you, hey, everyone, are points X and Y collinear? The answer is automatically yes. You don't even need to see them. You don't need to know where they are because any 2 points in the whole wide world are going to be collinear because there may not be a drawn line that exists, but there's a line that could be made that connects those two. And that's what it means to be collinear. Doesn't mean the line has to be there. It just means the line could be there. There is something that could connect any 2 points anywhere. That's so cool to think about. So I'm even going to add that. Any 2 points are collinear. You don't need a picture. It doesn't need to be drawn. Okay, we do the same thing when we step it up to a plane. Okay, so the next one is going to say that a plane contains 3 points. So another way to say that is that 3 points determine a plane. All right, now I need you to stick with me on this one. You ready? So we said I can make a line between any 2 points, right? Now, I had you put a random point A and a random point B somewhere on your paper. If you added a random point C, you can, feel free if you want to. If you add a random point C, aren't those 3 points that you made, A, B, and C, aren't they all on the same plane? That plane being your paper. So if I'll add one. Here's a random point C. A, B, and C are all together on the same plane. The plane being my paper. Now, I want you to sort of wrap your mind around this one because this is kind of weird. What if point C was not on the paper at all, though? What if it was like hovering up above the paper? So hold on. I'm going to erase my point C and I'm going to move it. And I'm going to pretend that I should get a smaller point for this, but here's my point C. It's kind of big, but whatever. What if point C were up here? So look here. Don't look on the screen because it's hard to see. Is there a plane that contains points A and B that are on my paper and point C that's up here? There is one. It's just not my paper. But if I took another plane, couldn't I connect all 3? Look at this. If I lined it up just so, I'm hitting the points on my paper and I'm hitting point C. There is a plane that exists that contains all 3 of them. Do you see that? And it wouldn't matter even if you had points B and C off the paper. There's going to be one plane that still connects all 3 of them, no matter where they are. Just like I can have 2 points anywhere I want and connect them to a line, I can take 3 points and put them wherever I want. And there's a plane that will connect them. Does that make sense? It's weird to think about. I get that. But yeah, I can connect them with a plane. Take any 3 points you want. It may not be, a physical plane that we have here, but if you could imagine a plane slicing, like we imagined the laser beam slicing through, but now you got to imagine that laser beam is like a whole sheet of zoom, zoom, that's slicing through, and it could connect all 3 points no matter where they are. Weird. I know. So we can say the same thing. Any 3 points are coplanar. So if I ask you, students, are points A, B, and C coplanar? The answer is immediately yes. You don't need a picture. It doesn't matter. It doesn't matter where they are. A, B, and C have to be coplanar. If I now ask you about a 4th point, though, if I say, hey, are A, B, C, and D coplanar? Well, maybe they are, maybe they aren't. And then you would need a diagram or something. What if I asked you, are points A, B, and C collinear? Could you tell me, or would you have to see it? You'd have to see that, because 3 points, maybe they are, maybe they aren't. But if I just name 2 points, they're automatically collinear. If I name 3 points, they're automatically coplanar. Oh, so cool. I know. I knew you'd like that one. Okay, so we are also going to add to this through any 2 points, oops, through any 2 points. Oh, I'm off, sorry. There is exactly 1 line. So if you take any 2 random points, A and B, and you connect them with a line, there's only 1 line that you can draw between them. You could draw that same line over and over and over and over again, but you're essentially just drawing the same line. So that's why we get to name lines using just 2 letters, right? So if I can name a line, line AB, that must mean that that's the only line AB, right? I couldn't be referring to some other line. So if I say draw a line between points A and B, there's only 1 line that you could draw. All right. Similarly, through any 3, remember they have to be non-collinear though, through any 3 non-collinear points, there is exactly 1 plane. I think we talked about this a little bit the other day. So I know we discussed why they have to be non-collinear. Okay, so next up we have if 2 points are in a plane, then the line that connects them is in that plane. This, I'm going to try and trick you in a few minutes. And if you remember this, maybe you won't get tricked. And the last of our postulates is that the intersection of 2 planes is anybody care to guess what type of figure? If you have 2 planes that really do meet, what does that intersection look like? Is it a point, a line, another plane, a ray? If you have 2 planes and they meet, what does that intersection look like? Let me give you a visual. Imagine the ceiling is a plane, right? Imagine the ceiling just went on forever. And imagine this wall is a plane that just went on forever. Look at where this wall and the ceiling meet. What would you call that figure? A what? Yes, a line, right? That corner, that edge, right? Where they meet, that we would refer to as a line. I know it's technically a line segment because it starts there and ends there. But remember, planes go on forever. So if you're imagining that these planes just keep going, the line will keep going too. So if you have 2 planes that really are going to intersect each other, they are always going to do so in a line. No matter how they meet, whether it's perpendicular, on an angle, it doesn't matter. Where those 2 planes meet will always be a line. So the intersection of planes, 2 planes, I'm sorry. I missed the word 2 in there, so stick that in there. The intersection of 2 planes is a line. Okay, we're almost done. I have 3 theorems to give you, and then I'm going to give you a picture and ask you some questions. And then, yeah, there's no way we're getting to multiple choice today. So so I guess what we'll have to do is tomorrow, we'll go over the homework for 1-5. And then I'll answer any questions you might have. We'll take the multiple choice. We'll go over the multiple choice, and then we'll have to have your quiz on Monday. I'm sorry, I don't like to give quizzes on Monday, but what can you do? Yes, sure. Okay, so the intersection of two planes is a line. First of all, let's define what a theorem is, because you know what? I'm going to flip the page though. So let me flip and we'll do theorems on the next page. Theorem is a proven statement. Okay, so these are things that I can prove to, like Pythagorean theorem. When we get there, I will prove to you the Pythagorean theorem that it works. You can mathematically show there's so many different fun ways. I even show you a video where people use water to prove the Pythagorean theorem. It's so cool. So anyway, the first theorem that we're going to use is that the intersection of two lines is a, what do you think it is? If you have two lines and they really are going to intersect each other, what does their intersection look like? A point. Yes. So here is my cool exploragons. If those are two lines, the right where they cross is always going to be a point. Now, I know you might be thinking, well, what if you did something like this, where you had the two lines and you sort of like overlap them like that? Now they intersect in a line. When we are talking about the intersection of two, whatever they are, we're talking about two, we usually use the word distinct, which means separate. This is two lines, you're just drawing the same line twice. That's all that it is. So we won't refer to these as distinct lines. So when we say distinct, we mean they are separate. It's not just one on top of another. So if you have two distinct lines that are going to cross, they're going to intersect at a point. Okay. In fact, I'll even throw that word in. The intersection of two distinct lines. Let's start putting that in play. Distinct lines is a point. Okay, next one says through a line and a point not on the line, there is exactly one plane. All right, let me sort of walk you through what's going on here. So let's say I have a line and let's say I have a point. So here is my line, here is my point that's not on the line. Couldn't you imagine a plane that connects these two things? Even if I move the point, there's still a plane that connects these two. It's nice and easy to see it flat on paper. So here's my line and then here's my point. There's certainly a plane that connects these two, it's the paper. But even if I took the point and I picked it up and I moved it, there would just be another plane. There we go, that connects them. So if you have a point and a line, and the point's not on that line, you can always connect those two things with a plane. Okay, and only one plane. You couldn't do a second plane. There would only be the one. Okay, and then the last one, two intersecting lines are contained in two intersecting lines are contained in exactly one plane. Move this up a bit. So for this one, I'm going to have two lines that intersect each other. And so here you can see, yep, they're both in the same plane. It's just your paper. Yeah.
Wouldn't it possibly be two planes if you have another plane run across the plane of intersection?
But then with you have to contain the entire line though. Yeah. So let's take my two lines that intersect and I'll put them up here. There's only one plane that's going to contain both entire lines, right? So no matter where these intersecting lines go or how you orient them, there's only going to be one plane that actually does contain them both. I hope that makes sense. Okay, so now let me draw the picture where I try and trick you. I'm going to ask you a couple of questions, but that's it for the notes, right? Yep, that's it. Okay, so remember how we draw planes. We do. You don't have to draw this if you don't want to, but if you want to, you can. But remember, I will upload it so you have a copy of it. So here's a plane, right? And I am going to draw, you know what? I'm not going to draw a second plane just yet. Let me do a couple of things. So let's call this plane P, and I'm going to put a couple points in it. Here's A, here's B. Maybe I'll have a point C. All right, let's try this. D. Okay, so let me just tell you a little bit about the diagram here. When you have a line where see how this one is solid and then it turns into dotted? This is how we're going to draw. Hey, I have this plane and then I have this line. I'm trying to draw in 3 dimensions. So this plane, imagine this is your desktop and this vertical line is literally vertical. So part of it's going to be up here and then the dotted line is underneath the plane. It passed through it. So it's literally as if I took a line and I stabbed it through the plane like this. So you have part that's above it and part that's below. Do you see that? So that's how we sorted, because how are you supposed to draw it in 2 dimensions, something that's 3-dimensional, but that's how we do it. So when you see that dotted line there, that means it's passing through, okay? And let me add one more point here. Let's call this point F I'm up to. So let me ask you some questions. Is point A in plane P? Yes, A is in plane P. Is point B in plane P? Yes. So if I were to connect points A and B, would line AB be in plane P? Yes, that was one of our things that we just learned. If 2 points are in a plane, then the line that contains those points is also in the plane. Okay, cool. Is point C in plane P? Okay, cool. Is point D in plane P? Thank you. The answer is yes. What? If it's in the plane, shouldn't it be in the parallelogram? Kind of, but remember this is 3 dimensions. And remember that planes never end. Let me ask you this question. Is point D on line BC? Yes, it is. And B is in the plane, right? And you said C is in the plane. So isn't line BC in the plane? So if point D is on line BC, then it's in the plane too. Planes never end. This, I could have drawn this parallelogram way bigger and then it would have looked like it contained D. But if any 2 points of the line are in the plane, then the whole line's in the plane. The whole line, no matter how it's drawn, because it all goes on forever, right? Weird. Okay, let me ask you this. Is E in plane P? No. I know. Remember that line, BE. PE is doing this because that dotted part, it's cutting through. So B is the point where the line meets the plane. And then E is something down here. So E is not part of the plane that's represented by my piece of paper. Does that make sense? Oh, it's weird. Is F in plane P? No. Is line BF in plane P? In order for a line to be in the plane, the whole line has to be in the plane. Is all of line BF in plane P? No. Where does line BF and plane P intersect? Someone said it, at point B, right? Isn't that the meeting point? Yeah, that line and that plane are meeting at point B. Ooh. Is line EC in plane P? No, because E is not on plane P, right? E is not on, it's down there. So if I had a line between E and C, it would not be contained in plane P. Are points E and D collinear? Ooh, I got a lot of you in my devil's snare already. The answer is yes. Any 2 points are collinear. You don't even need to look at the diagram. If I just say 2 points, the answer is immediately yes. Because remember, it doesn't mean, is there a line drawn? It means, could there be? Could you draw a line between E and D? Of course you could. Are points F and D collinear? Yes, you don't even need to look. If I just say 2 points, you don't even need to check. Are points A, B, and C coplanar? Yes. Are points A, B, and C collinear? No, now you got to look, because if it's 3, you got to look. Are points A, B, and F coplanar? Yeah, if it's 3 points, it's automatically a yes for coplanar. Doesn't even matter. You don't even need to look. Are points A, E, and D coplanar? Yes, automatically. Okay, does this make sense? Oh, they're tricky. I know. I appreciate the trickiness. That's part of why I love geometry so much. But anywho, I know some of you are like, what? This is why I hate it. No, you don't think that. Okay, let me give you your homework so you can get started on it. It's going to be page 25 to 26, numbers 13 to 19. That's it. Okay, I'm gonna post this on Jupyter so you can submit it when you're done. I don't think it's there yet, is it? No. Let me sign that. Yes.
So one of the questions is there's 2 points of line into 2 lines. Does that just mean? Does that mean that 2 points
Oh, it's say whether it's possible. Oh, this, how could that be? It's impossible. You can't have 2 points that are both in 2 different lines. Yeah, that's all. homework. What is this? 1-5. Page 2.26. 18 to 19. Due tomorrow. Oh, I gotta stop the video.